Okay, so with the very start of the video, in general, all these data types have been given a term. What was that term? Bucket, that we say just to make you understand in the programming language context. Primitive data types, yes, primitive data types. Okay, so what we are talking about are the primitive data types, right? So here I am creating a table, but just before the table, let me write these tables are for primitive data types. Now, why they are called primitive data types? Primary, it's okay. Primitive, what is the literal meaning of primitive? Old, from stone ages, right? So that means right from the evaluation of the languages, programming languages, these data types are generally found in all languages. Okay? Even in most of the advanced languages, there is a possibility that new things are coming, but these are bound not to go. Okay? So these are called as primitive data types, right? So if there is something called as primitive data types, there must be something which is non-primitive, right? So such data types which are non-primitive are generally called as user-defined data types. They are called as user-defined data types. Primitive data types are something that belong to the language itself. They are in language, okay, or almost in every language, okay. So then we can classify the primitive data types into different categories. One category is which can store whole numbers, है ना? To make you understand, I call them buckets. So those buckets which can store whole numbers. So these data types are typically of four types. ठीक है? I am listing them uh, in ascending order of size. ठीक है? So byte is the smallest data type that can store whole number. ठीक है? Size 1 byte. ठीक है? So size in bytes is 1. Larger, a little larger data type which can still store a whole number. ठीक है? It's called as short. It's of the size 2 bytes. Fine. Then something which is more larger than short, but still it is meant for whole number only, is integer. Keyword is int. So these are the keywords. Okay? Mostly that you will find in most of the programming languages. Things vary according to the implementation of the languages, right? Their compiler, even for single language also, the compiler may vary in implementation. Okay? Like we get products from different companies, right? So there are sometimes compilers even for the same language from different groups, right? Different providers, so they may have some variation. Okay? But this is something what I am telling you is general for across the languages. Okay? Then a larger bucket or a larger data type, primitive data type, for the whole number is long, right? So for int it was 4 bytes, and for long it is usually 8 bytes. Okay. Now these are all four are for whole number. Now for the fractional part or the decimal numbers which may contain the digit as well as fractional part. So these are called as floating point numbers, like the water bucket that stores the water as in the video, right? So these are called as floating point numbers. So there are two data types for storing the floating point numbers, right? One is typically called as float, right? It is of 4 bytes. and the other is double, that is of usually 8 bytes. ठीक है. So first four, these four, byte, short, int and long, they are basically meant for integers or whole numbers, right? So I will just color them with yellow, right? This float and double, they are meant for floating point numbers that can store fraction. I will color it with a different number. Okay? So one color means they have a same nature, only the size is different. Okay? Then we have got something called as char to store a character. Usually the size is 1 byte. Usually. Then there is something called as boolean, right? And logically, what should be the size? It has, okay, what is character? A, B, C, D, small letter, capital letter, even a number can be also stored as a capital, special characters, all these are characters, right? So they require 1 byte, right? What is boolean? True, false, true, false. True, false can also be interpreted as 0, 1, yes, no, right? Pass, fail. So all these such situations where we want to model them, they are called as, they need the boolean data type, right? So logically, it seems if I just go with 1 bit, 1 bit can store two values, 0, 1, right? Right? 0, 1 in binary, right? So that means I am done with, that is the maximum size I require, size. So this is said to be the smallest size or the implementation of any data type. But you will see that most of the languages, they use, in reality, including C language, they use 1 byte. Okay? We will just see it. Okay? We will make a program and we will see the size also. We will test the size. Okay? Logically, it makes sense. 1 bit is fine. But the implementation is such that in most of the languages, that the actual size that is consumed or reserved is 1 byte. Okay? But you just uh, if you have just a true and false relationship, make sure not to use this byte or this character which are again 1 byte, rather use boolean only, because logically also that makes sense. Okay? And there are reasons like optimization by the compiler and so on. Okay? So if you have a data type which has got which a question which could be answered in either yes or no, true or false, okay, pass and fail, always make sure you are going to use boolean, not char, not byte. Okay? Okay guys? Okay. So let me open code block. So int is for counting objects. Like if I need to count the students in the class, I will use int. Float is for measuring things like temperature, marks with decimal, and so on. If such kind of data is required, you will store float. Char for a single character like grade A, B, C kind of thing, first letter of a name and so on. Okay? So variables are container. Different containers have different capacity and users. We have just seen that, right? Okay. So I keep on making a note also for you at last or after a few days, say weekly basis. I will provide you the notes also, whatever we discuss, so that you can go through that also. So let me see, this is the code block, right? Let me create a new project. I will use, for a new project, I will use a console application, right? Console application. Once I say go, next, I will have two options, C and C++. Okay. I am looking for C, so I will choose C. I will say next. I will have to give project title, demo primitive data type. Okay. Then I say next. It is telling me which compiler I am using. So you can see there are lots of compilers. These are provided by different vendors. So there are lots of compilers. Normally, we use either GCC compiler, right? Or the other compiler is MinGW. So there are two kinds of compiler which are largely used. Okay? So this is the default compiler I have chosen as GNU GCC compiler. Okay? Here you can see wherever the project folder is being created, in the project folder, it is saying that it is going to create a bin folder and a debug folder. Okay? That will contain the output directory for your exe files. Okay? And similarly, there is something called a release, right? For it also, there is a directory created. Okay? Sooner or later, we will try to open those directories and we will see, we will try to figure out what's lying in those directories. Or you can also open it and just wander around. Okay? Let's say finish. So first project is created. The source contains a default file, which is the main file. That main file is generated. I have already told you what does include means. In short, right? So if you can see stdio.h, what does this mean? Standard input output. .h means it's a header file. It's a header file, right? So the header files, if they end with .h, so you know that they are already there with the language provider and we are using it for some purpose. Like if I want to do some standard input output operations, the standard input output operation means I want to read something from the keyboard or I want to print something on the screen. So they are the standard input output operation. So this stdio.h contains some function for these operations. Similarly, there is something called as stdlib.h. This is again used very frequently. It contains lots of function which will we are going to soon see and use. So the main function we have discussed already. What is the main function? The name main indicates something. The place where our code was. This is the first entry point of the code in almost every language. Okay? So in any language, if you see something like at main and then there's a opening and closing parenthesis, you understand it's a function. It's a function, and this particular function which has the name main is called as the main function. So there could be many functions. There could be many such functions, but the control will only enter in the main function. That means the program will start from whatever is written in the main function only, nothing else. Okay? So how do we know it's a function? A function is defined as a set of statements. So you can see two statements are written over here. One is printf statement, the other is return statement, right? So these are the statements. Statements are meant to do something. Correct? So this is a file. File, first of all, contains whatever existing feature which is available in the header. Those we want to store, we want to include in our program. So that is included first. Then what you will see is the main function. The main function is the entry point from where the program enters the execution. Okay? Or starts the execution. The main function is, or any function just in general, has got an opening parenthesis and a closing parenthesis, these two, right, brackets. And the function, because it contains multiple statements, so we need to figure out from where it starts and where it ends. So we have got this curly braces, starting curly braces and the ending curly braces, right? So they indicate the start and the end of the function. Okay. For some of you it is very basic, but I'm uh, assuming that a lot of people are totally beginner. Okay. So we will start from the beginning and soon we will catch over time. Okay. Now this main function, as the name indicates function, it is also called as methods. Okay. They are the behavioral part. Okay. They are the behavioral part. That means they are meant to do something, right? For example, here the printf statement is within the main function, and that is meant to print something. Okay. So a function will contain statements which are meant to do something. Okay. In a program there could be two things. One is that part of the program which is representing the information about the program which the program is going to use. That is called as data. And we have just seen the primitive data types are those data types which are predefined and exist in almost all languages, right? And they are meant to categorically store data into the containers. Okay? The containers will go into memory at the runtime. That is the RAM, right? Just before the name of the function, this int or float, or you can add char, you can add just any data type, any primitive data type. Okay? Before the main function, right? And this is a promise that this function is going to return a value of the promise type. So the promise type is integer. So I am not going to return a character here. I am going to return only a whole number, which is the integer. Okay? So if I put a float over here, then I will have to return 0.0. If I put a char here, then I will have to return under single quote, say a character X, and so on. Okay? So this could change. Okay? This could change, and but whatever the promise is, the promise must be fulfilled by returning that nature of value. Okay? We have also discussed in the last class that in the main function, because the main function is run by some external code, which is called as which is called as a runtime for that particular language. So it's an indication if 0 in general or any positive value is returned in general, that is an indication or a message sent that everything has worked well. If there is a negative value, that's an indication that something has wrong, something has gone wrong. Okay, fine. Okay, so let's now try the primitive data types that we have just discussed, right? Printf function is available in which header file? stdio.h file. Okay, standard input output dot header file, right? So this is meant to print something on the console or the screen, right? So I am printing message size of int is percentage zu. Yeah. चलेगा percentage zu bytes. ठीक है. And This is called a size of operator. Okay? This is called a size of operator. I am typing the data type int, right? Okay? Let me save it. Let me just run it and see. Size of int is 4 bytes. Okay? Size of int is 4 byte. Okay. Now, instead of this statement, if I had a variable, say int I is equal to 5. Okay? Int I is equal to 5. And I want to print the size of I. Here I am directly giving the data type, right? I am printing the size of data type, right? If I want to print the size of variable, okay? So I will, yeah, I will just repeat this statement, Control C and Control V. Instead of int, I can also write here the variable name, which is I. Variable name is what? No, what? How it is defined? It's like a label. It's like a label, like label to the container, which is storing, because it's int, which is storing a whole number, right? Correct? And why it is called variable? Value कुछ भी assign कर सकते हैं, because as of now it has a value 5. I can print the value of I as value of I is equal to, and then here I will use percentage %d, right? See the difference. Here I have used percentage %zu, again percentage %zu, wherever size of is being used. But if I want to print a numeric value, a whole number, I will use percentage %d. D, you can assume it to represent a digit, right? But number is not just a digit, but okay. It's a whole number. It's a numeric value. Okay? And here I will say the name of the container or the label of the container, which is I. Okay? So, and here also I am going to print the value of I again. But before that, I will change the value of I to I is equal to 7, right? Okay. So int I is equal to 5. The left side of equal to is called as declaration. It is called as, yeah. नहीं बता रहा हूँ. I'm just telling. The left side of this equal to of statement number 6 is called as declaration, and the right side is called as initialization. If I would have wished, I could have done it into 2 steps also. Like for example, I should have terminated it over here, and then I is equal to 5. Okay, so both are the same thing. Instead of one line, I have written 2 lines for the same purpose, right? So initially, it's just a declaration that there is a container. The container is empty. Okay, and then in the container, I am putting the whole number 5. Okay. Now I am printing the value of the container. I will assume the message value of I is equal to, and then 5 should be printed. Okay, this is what I'm expecting. Then the size of integer will be printed as 4 bytes. Size of I is again printed as 4 bytes, right? Then I change I is equal to 7. Why I do not write int I again? Because if I say int I again, then that will be duplicate declaration attempt. So I will get a compilation error in that case, that these two declarations are duplicate. So I cannot have two labels for same tables for two different things. ठीक है? So I do not need to say int I again. Rather, the same container which was earlier containing the value 5, what I wish to is to remove that value 5 and now place 7 into it. If 7 is placed successfully, then my next attempt to print it would should result value of I is equal to 7 now, right? And that is why we call it a name as variable, because the value could vary over time. I can replace the value, put a new value. Okay? So let's try to run it and let's see. Okay, now there's a problem. Everything is coming in one line and we are confused, right? So let me just correct it. Let me correct it. What should we do? Where? In the message. Message is always in double quotes, right? So backslash n means after this message is printed, create a new line. If I would have said backslash n before, then a line would have been empty line would have been printed and then the message would have been printed. Okay? So if you put it before the message, a line will be skipped. That means a line will be printed. A blank line will be it will go to control will go to the next line and then print the statement. And if you do not put it in the beginning, you put in the last. Then after printing the message, the control will come to the next line for next print. Okay? So this value will printed. It will come to the next line. It will print this value. Again for this value, after this value, I will say backslash n. After again this value, I will say backslash n. If I have just these four messages to be printed, do I need to put a backslash n over here? No need, because this is going to be the last line. I do not need to go after that. Okay? Correct? So let me just save it and run it. Value of I is 5 initially. Size of int is 4 bytes. This first message is coming from size of int statement, where we put the type itself in the size of operator to check. Size of int is 4 byte. This message is coming from the statement where we have used size of the variable name or the label I. Because that is of the integer, automatically it is figure out that this is integer and 4 bytes is printed. Okay. Then the value of I is 7 is printed because we have overwritten the value of 5 to 7. Fine. Any questions till now? int और I 4 बाइट कैसे हो रहे हैं? अभी मैंने आपको ये दिखाया ना इसके लास्ट में जाकर के. Int has a size of 4 bytes. Yeah. 4 bytes. 4 bytes means 32 bits. 32 bits means this is a signed data type. Signed data type means which needs plus or minus sign. Carry is not a signed data type, right? Int is a signed data type. So that means 4 byte means 32 bits and 1 bit will go to store the sign plus or minus with 0 or 1. Okay? So we have got the space of 31 bytes. So this is fixed that I can store a range of value starting from minus 2 to power 31 to coming to 0 and then plus 2 to power 31 and this whole value minus 1. This we have discussed in the previous class. Okay? So this size actually determines the range of value that you are going to store. You cannot go beyond that range. Okay? For that particular data type. Otherwise, something bad may occur. Okay? Yeah.
This size of I use after the operation.
this size of and this int. Size of is called as an operator. It is called a size of operator. It's like a function, right? In parenthesis that takes something, right? But it's basically called as size of operator. Okay? That gives you the size of a particular data type. Got it? Is this what you were asking? Okay. So this can take either the data type itself directly, the keyword of the data type. So int is a keyword to represent integer type data type, right? Or a whole number of containing 4 bytes. Whereas I is the label or the variable name. Okay? This is I. So I can use either int or I. Both will work. Okay? Because I is of the type integer, that's why it's already automatically it is translated to 4 bytes. Okay? And the 4 byte is printed. They both are the same. Okay? Let's say we have got short, right? Short s, right? As of now, this is just declaration and not initialization. If I write equal to 76, for example, now this is initialization. Okay? As of now, it is just declaration. It doesn't contain any value, right? So if I want to use this size of for the variable name, I will just copy it over here, and after the print statement, let me uh, go here. Okay? Just to avoid the confusion, I am going to comment these lines so that only one message is printed. What is a comment? A comment, this is what I am doing is slash slash, right? This is a single line comment. This is called as a single line comment. So what it does is, let me write here, it's a single line comment used in most of the programming languages, if not all, okay? But in most of the programming languages, okay? And this means on whatever statement that is supposed to do something, if I put this double slash before them, the code will be written over there in the file, it will be preserved, but that code will not execute, that code will not run. So all these lines which are under slash slash, right, or within the single line comment, they are not going to execute, they are not going to give the output. Only this printf statement which is without the single line comment, this is valid for execution. So the single line comment could also be used to temporarily disable any of the statement that you do not want to use as of now, but you want to keep it as a code. Maybe you need it for some other time. Okay? You may change your mind. Okay? Or it may use to write some kind of documentation. Okay? Like here, I want to write a documentation over here. Let's say I am printing, I am printing, or the size of variable s, for example. Okay? Let me comment this also, and let me copy this. See, okay? And here in the size of, let me write s. Correct? So this is a comment. I am printing the size of variable s, and then within size of operator, I have put the variable name s, even though s has not been initialized, right? So let me just run it. Size of the message will come wrong. ठीक है, I should change the message. Fine. ठीक
सर वो साइज ऑफ इंट इज इतना शॉर्ट हो गया
है.
सर स्टेटमेंट में साइज ऑफ इंट इज परसेंटेज दैट यू शॉर्ट
ओके, यहाँ भी करेक्ट कर देते हैं. द साइज ऑफ,
लॉजी ले रहा था लॉजी ले रहा है
नहीं उसने यही के लिए बताया था, मैंने ध्यान नहीं दिया. यहाँ पे बाइट लिखना है ना, यहाँ मुझे बाइट लिखना है एक्चुअली. आई नीड टू राइट बाइट हियर. ठीक है, नाउ इट्स फाइन राइट. ठीक है, ठीक है, वॉट एवर मेक सेंस. ठीक है, करेक्ट. लेट मी build and run. So the size of short is 2 bytes. Okay, whether this s contains a value or not doesn't matter. Okay, instead of this I could have also written as the keyword itself, like short, right? This is also going to give me the same value as 2 bytes. ठीक है. Guys, correct यहाँ तक. Let's try to explore the size of few other data types also. I'm going to copy this statement just to save time. Printf size of, we have seen the size of uh, int, we have seen the size of short. Let me see the size of char. ठीक है, char is, let's say, carrier, right? Then let me do it in one go. Okay, then we want to see the size of, okay, even before boolean, let me say, let me go for the size of long कर दे. चलो, long, correct. Then again let me print the size of float. Float, correct. Let's say we want to print the size of double this time. Just notice all these keywords to denote the primitive data types, they are starting with small letters, right? So every keyword starts with a small letter. ठीक है. Okay, let's just run this much. ठीक है, int is already done. चलो int के लिए मैं इसको कर दे रहा हूँ size of double. Okay, double. ठीक है, चलो ठीक है, करें. Size of short is 2 bytes, size of int is 4 bytes, size of char is 1 byte, right? Size of long is 4 byte. अभी हमने क्या सीखा? It should come 8 byte, but surprise. Okay. Size of float is 4 bytes, fine. Size of double is 8 byte. Okay. Now the thing is, why this size of long is coming as 4 byte? I told you it also depends upon the implementation of the compiler, right? Ideally, the long should be 8 byte. So the says specification says that it should not be less than 4 byte, and it should go till 8 byte. ठीक है. Similarly, for the integer also, the specification says it should not be less than 2 byte, but the maximum size is 4 byte. Now the implementation this compiler has done is that GNU GCC compiler has done is that for integer it is taking the 4 bytes, that's fine, but for long, and this is also promised for the 64-bit machines. Okay, so depending upon maybe this code block is meant for 32-bit machine, or the compiler that I am using, maybe it might be meant for 32-bit machine. There the value has been taken as 4 bytes for long also. Okay, now I want to make sure that the bucket size should be strictly 8 bytes only. So what I need to do is, instead of long, what I will do is I will just copy this, and let's see the size of, instead of writing long, I will say long. Okay, and here I will do long. Okay, now let's try to build. Sometime if it is stuck, you have to abort it. Okay, जो already code चल रहा है, and then go build and run. See, the size of long is 8 byte. Okay, so if your compiler is not taking long as 4 bytes, 8 bytes, then in that case use long. Okay, if you want to use or have a bucket size of 8 bytes. ठीक है? हाँ. See, there is nothing like maximum. You can also have a user defined data type which may use, say for example, I have a very large value. Okay, I I know that it will not come within the long itself, but I will have to use it for my computation somehow. I'm doing some scientific application. Now I will break it into two parts. And I will create a user defined data types that may contain 2, 3, or 4 different long values. Right? I will put one portion of that value into the first variable. The second portion of the value, sliced value, in the second portion, and third in the third portion. Now, how I am going to use it for addition, multiplication, and division? For that, I have to write my separate algorithm. But the size could be managed, even if it is not provided in the language as a support. Sometimes there are libraries, third-party libraries, that give you predefined size that you can use. Okay? And those are user defined. Those are not primitives. Those are user defined. Okay? So there is a solution, there is a workaround for every situation. Okay? Every constant that you will see, there is a workaround. But then you will have to figure out the workaround. Okay? Done? Any more questions? Okay. Now note the difference that when I try to print the value of I, this I in this statement in line number 14, which is of the type int, right? I have used percentage %d as a placeholder, that after equal to whatever value you are going to fill, that has to be of the nature of percentage %d, right? Let me see, say if I change the value to C, percentage %c. C means for character. Let's see what happens. Let's see what happens. क्या प्रिंट नहीं किया उसने? I. Value of I is, it has not printed, right? Okay, incompatible ले लिया उसने. Okay, I will change the example to this. Say for example, instead of int, this I is char. ठीक है? I will tell you the reason of the discrepancy later on. फिलहाल just to understand as of now. Now let me try this now. ठीक है? If this would have been percentage %d, what will be the output, and if this is percentage C, what will be the output we want to see. Okay, we will start with percentage C, build and run. But before that, let me say backslash n so that we are not confused. Okay, sometime it takes little time to compile. The value of I is okay. Just a second. Let me replace a character. Okay. Then I will expect C to be printed, right?
सर लेकिन वो नीचे भी तो I is equal to 7 है.
अच्छा अच्छा ये अच्छा अच्छा critical problem. Okay, fine. अब सही है. I has a character C, and I am printing I with the right indicator, the right type of placeholder, that is percentage C. Let me see first this. Now you see I is equal to C. Correct? This is what we were expecting. That's normal. Now what we do is, instead of this percentage C, let me do D here. Okay? Let's see. Value is what? 99. 99 is the ASCII key for C. So whenever you see it is not printing anything, that means it doesn't make a sense over there. The conversion doesn't make a sense. So in order to print it, it has to make sense. So here, if I am trying to print a character in the form of a digit, I am making sense because I want to print actually the ASCII numeric value of that particular character. Okay. Otherwise, whatever places you have seen it is not printing, that means this thing is not compatible. ठीक है. ओके, आपसे प्रॉमिस किया था जल्दी छोड़ देगा. ठीक है. ओके.